Okay, final short question here for the 2020 mock paper. Let's get straight into it. So first things first, we can see here we have an iPad that's sloped. Complete the elevation of the slope screen. We can see we have our edge B and C appear to be on the ground. Therefore, if we bring C up, we will find it straight away on the XY line. So I'm going to do that straight away. And then we can also project across to find D. So I'm just going to project up all the points right now. And I'm going to line up with the line BB. There we go. I'm going to bring up that internal screen. So we have C right there. And now while I'm at it, I'm going to find point D. So I could either come parallel to AB, which I might actually do, because they're parallel. If these are all parallel, then it's parallel in every view. Therefore, finding C means then I should have found D just here. To double check, I can come parallel to my XY line because BC should be parallel with AD. And surely they do intersect. Boom. Okay, now to find AD, or not AD, sorry, the internal surfaces here now. So to find the internal surfaces, we cannot find how high this point is, but if we imagine that this line extended on and hit AD, we can find that point. And similarly, we can do the same for the point on BC. So what I'm talking about is, if I take this line here, I'll zoom in a little bit so you can see. So if I take this line and I touch both AD and BC, now if I bring those points up, this one here is right there, and this one here right there. I only really needed one because I can come parallel. There we go. And where this, there we go, where this line touches, that gives me 1 point, and where this line touches, that gives me another. And then I can do the same on this side. But before I do that, I'm going to come across horizontally. Actually, no, I don't need to, because I can come across horizontally, can't I? So we only need to do that on one side. And my page keeps moving. There we go. Join them up. Again, parallel. Everything looks parallel. A little bit lower here. Could be just where I took my points and print, but it looks quite good to me. And the next thing is to find the true shape of the surfaces. Now, looking perpendicular to the surface or anything here doesn't really work out. So what we can do is we can actually find the true length of one edge of this surface. So we already have the true length of BC. So all we need to find is the true length of DC. So to do that, we could either rotate it down flat, DC up here, we could find the true length in plan, or we could just rotate it along so that we get the true length and then step it down in plan. And that's, I might do, yeah, no, I'll do it that way. So what I'll do is I'm going to draw a line parallel to my XY line. Basically represents a vertical plane. I'm going to rotate C up so that it is a rebat. There we go. C will have moved across now. And it will be just here, and that there will now give me my true length. Therefore, if I was to extend DC down this way and AB down this way, all I need to do is take that true length, step it off there, step it off there, and we have the true length of BC. The true shape, sorry, of A, B, C, D, T, S. And that is that question done too. Right, I hope them videos helped. Thanks.